And hello, welcome to Code Live. Today we are going to learn how to build AI applications and deploy them to Heroku. My name is Julian Duque. I'm a principal developer advocate at Heroku, working for Salesforce. And here, this is Code Live. Okay, let me show you a couple of resources before we start. So let me share my screen. Remember that we have the Salesforce developer website where you can find all of the different resources we have available for you. Our latest blog posts, podcasts, videos, and documentation resources that you can find to learn more about what we offer for you. Also, the Salesforce developers channel where you are seeing us right now. As you can see here, I'm live. This is not pre-recorded. Here you can take a look at the upcoming live streams so you can learn more about what we have for you. For example, next week, if I'm not wrong, I will be sitting down with Ashwin. Now we're talking about how to build and debug LWCs for mobile offline use cases. And then Philippe is going to talk about integration with AWS, about the new LWC features for Experience Cloud. We will have an AMA about Apex. So stay tuned. Click on subscribe and on the notification bell so you don't miss any content we have for you. As you might have seen from social networks, LinkedIn and X, I recently changed teams. Right now, I am working directly for the Heroku team, but I will be continuing creating content in this channel, sharing about how to integrate Salesforce with Heroku, how to work with Heroku. So don't miss, I am going to stick around, even though I am going to be with other teams. Also, if you go to TDX, Dreamforce, or other Salesforce events, make sure to find me. I will be there and I will be more than happy to say hello. So remember, if you want to learn more about Heroku, you can go to heroku.com and take a look at the products we have. Heroku is a platform as a service where you can deploy applications that are built with open source programming languages like Node.js, Ruby, Java, PHP, Python, Go, and other subvariants of Java. And today we are going to be using Heroku to build AI applications. Take a look at the recent blog post that we have published on blog.heroku.com, specifically this how to use PG Vector for similarity search on Heroku Postgres, because this is what we are going to be using today. We are going to be using a extension called PG Vector for the open source database PostgreSQL that will allow us to store vectors and turn PostgreSQL as a vector database. Vectors are important in AI development because it allows us to perform a lot of different use cases. One of those cases are similarity search. We are going to store text, specifically in this example, we are going to store text in vector representation on a database, and we will be able to search on that database by sending a query and perform a similarity search using, I will say, some mathematical operations that the database does for us. We don't need to learn the math behind. We are going to learn the engine that the math for us. But I will be showing you a basic example, and then we will build a more complex example and deploy it to Heroku. The complex example that we will build, we will use an open source framework for building AI applications called LangChain. LangChain is very popular in both the Python and the JavaScript ecosystem. You can build AI applications with this framework, and we will be using the Node.js version of LangChain, which is called LangChain.js. We are going to be using JavaScript to build a server application. We are going to build an API that will perform two things. One, we are going to pass a YouTube URL like this video once it gets recorded, or any other video that has been published on the Salesforce Developers channel. and the application will extract the transcripts, will extract all of the subtitles as text. Those texts are going to be vectorized, are going to be transformed into a mathematical representation that will be stored in the vector database. Then we will be able to ask questions to that video. For example, when I publish this video, I will be able to ask questions like, what was the framework used to build the application? And it will be able to reply, the framework used to build the application was LangChain. How is this possible? This is possible through a technique called retrieval augmented generation. We are going to retrieve those pieces of context that are stored in the vector database, and we are going to augment a prompt that we will send to OpenAI or to a large language model. And the large language model is going to find the answer in that context and reply using natural language. So the question we will ask will also need to be converted into vector, and we will do a similarity search, an operation that will bring all of the pieces of context that are stored in the database that are similar to the question I am asking in this mathematical dimension, in this vector dimension. We will get the answers. With those answers, we are going to build some sort of mega prompt, and with that mega prompt, we will get the responses. This sounds a little bit complex right now, but step by step, we are going to untangle this and understand how to build contextual-based AI applications. If you have any questions, please let me know. I am taking a look at the chat and I will be able to reply. Okay, for this, I am using OpenAI APIs. You can create an account and it will give you some credits, but depending on how much do you use this application, you might need to pay for the service. I've been using OpenAI for a while, and I must say it is very cheap. So you are not going to get any high charges by building this demo. I've been using it for a while, and it has been just cents. But for high production applications with a lot of traffic, you might need to take care because it costs. Also, with Heroku, you can use for the dyno, you can use an Echo dyno, which it's around $7. And the vector database option, it's only available on production databases, starting from a standard 0 PostgreSQL. If we go to elements.heroku.com, we will take a look at Heroku Postgres. Let me see add-ons. What is Heroku Postgres? The PG vector is available on a standard 0, which is going to be a maximum of $50 a month, but you can use it hourly if you want to try this feature as well. Okay, let's start building the application. I already created an Heroku application. It is called JDuque Heroku PG Vector. And I added my OpenAI API key already in the configuration. But I don't have anything here. I don't have resources. I don't have PostgreSQL. I don't have any dyno. So first, let me add PostgreSQL. So I'm going to be searching for PostgreSQL. And from here, I'm going to select the standard 0. This is the minimum version that has PG vector support. I'm going to submit the order, and this is going to provision the database in my application. This is going to take some time. We can go to the terminal, for example. This is the application I already created, and we can run Heroku PG wait, and it will let us know when the database is ready to use. Once the database is ready to use, let's create a basic example. We are going to create a table that has vector support, and we will store some vectors, and we will perform a a distance search. We are going to store mathematical information, or we are going to perform a query to get those vectors that are going to be closest to the vector I'm searching for. If you want to take a look at the documentation for PG Vector, let me search PG Vector on Google. It's the repository. It's called PG Vector and the org PG Vector on GitHub. And here you can see how can you enable the extension once this is installed on PostgreSQL. How can you create a table with the type of vector? In this case, we are creating a vector with 3 dimensions, and we are inserting values. The values, as I mentioned before, it's a numerical representation of a vector, and we can perform different operations, like calculating the distance, the cosine distance, the inner product. To be honest, this is math that I don't understand yet. I'm studying this topic and I need to get deeper into the math behind. This is a very interesting subject. But today we are going just to give it a try, see how it works, and then building an application on top of it without going deeper into the math. Okay, let me see if the database is ready. Database is not ready. So while the database installed, let me go and do other stuff. I have Visual Studio Code here. This is where we are going to build our project. I have a .m file. This .m file is the one that contains the OpenAI API key. I'm not going to open it because this is a API key that anybody watching this video can use. Yeah, sure. I can disable this API key later, but let's, for security reasons, don't do it. I'm going to be using Fastify, which is a web framework for Node.js to create the API. You can see other videos from myself. I have built other APIs with Fastify. We are not going to be covering all of the details of Fastify. We are going to be focusing on the AI aspects of the application. So I already installed the Fastify CLI, so I'm going to be running generate. I'm going to generate the project in this folder. I'm going to integrate that project with this folder, and I am going to use ECMAScript modules. This is going to generate a Fastify project in my current folder, and then I will install the dependencies with npm install. If for some reason I lost my voice, is because right now I'm a little bit sick. It seems I caught a flu or something on my trip to Colombia. Let's hope I'm able to finish this stream without any issues. Okay, so I'm installing the dependencies for this project, and basically Fastify, it's giving me a project structure. The app.js is where I'm going to be placing custom code. There are like certain plugins that I'm going to be using to enable, for example, OpenAPI spec, Swagger, and other features on my web project. And on routes is where I'm going to be creating my API routes. I am going to be adding a couple of API routes, one to load the document. Remember, I'm going to be passing a YouTube URL, and I'm going to extract the text from that YouTube URL and store it on my database as vectors. And the other one to perform a query. The query is going to be a question. The question is going to be also vectorized. I'm going to be extracting context from the database, and I'm going to be sending a prompt to the LLM to get the answer. Thank you very much, Akbar. I am hoping the same. Okay, let me see if Postgres is already installed. Yes. Before we start building our application, let me show you the PostgreSQL bit. This is a freshly installed PostgreSQL application, okay? So, where are you? Here. So, let me, using the Heroku CLI, go and open the PostgreSQL REPL. Here, I will be able to create the database, but before creating the database, I need to enable the extension. To enable the extension, I will need to type create extension vector. Since this database already has pgvector support, I can create the extension without problems. If we don't have that support, it's going to give us an error. Then I will be able to create a table. I don't have any tables on my database, so I'm going to be creating a table to perform some basic queries. So let's create a table called documents. It's going to have an ID. The ID is going to be the serial, so it's going to primary key. It's going to auto increment numbers. Then I'm going to be adding a name, which is a text of 100 characters. And then I'm going to create the embeddings, which is going to be the vector with 3 dimensions. So I'm creating a database that has just a name and the vector. And the vector just has 3 dimensions. Now let's start inserting documents. I'm going to insert a document with the name and the embedding, and the values are going to be, this is the 1, and I'm going to be adding a vector. Let's say my vector is 1, 0, 0. Let's insert another 1, 2. This is -1, 0, 0. And let's insert another one, which is 3, -1, 1, 1. So you get the idea. I'm inserting different numbers that are going to be positioned in this 3-dimensional space. And then I will be able to query those and getting the distance, for example, of one specific vector I'm going to add with the vectors that I inserted in my database. So let me select the name and the embedding from, so the embedding, let me do the operation. I'm going to be calculating the distance within a vector that I'm going to be passing as the reference vector. Let's say that the reference vector is going to be 1, 1, 1. This is the one I am getting the distance for. This is called distance. This is an alias. And I'm going to be ordering those by distance. Column name doesn't exist. Oh, from documents, sorry. Perfect. So I am selecting the name and the distance, which is the operation between the embedding and the vector 1, 1, 1 from the table documents, and I'm ordering those by distance. If we see the closest that we have here, or the lowest, the distance is the closest vector to 1, 1, 1, to the one that I am passing. Let me get the embedding so we can compare. If we pass exactly 1, 0, 0, the distance should be 0 because I am exactly getting the same vector with the vector I stored. So this is performing a mathematical operation to calculate the distance between those different vectors. So what pgvector does is adding these mathematical capabilities into PostgreSQL. But here we are using 3 dimensions. These are not complex operations. With the embeddings, we are going to be using from OpenAI, where we are going to convert a lot of text into vectors. This is going to give us multi-dimensional embeddings. This is going to be on the 100 or more dimensions. So performing those mathematical operations over that amount of dimensions is going to be a more complex task, and pgvector is going to perform that task like on a performant way. This is why this is so powerful. This operator, if we go to the documentation now that people is asking, we have different operators. One is the I have the operators here. Where are the operators? to show you in the documentations. One is the Euclidean operator, is the one I'm using. Let me search Euclidean. Yes. This is called the Euclidean distance. The other one is the negative inner product, and the other one is the cosine distance. So this is like a different mathematical operation to calculate the distance between two vectors. Okay, but I'm not going into those details. I just wanted to show you like the very basic way to query that information using pgvector. Now let's go and use LangChain, use the framework to build our solution. Okay, let's do it. Now let's quit. Let's keep it that way. And what we need is to install. We will need to install LangChain, which is the framework that we will use. And we will need to install PG, which is the driver for PostgreSQL. We will need to get pgvector. I think it's called pgvector node, the driver. But for this example, we don't need it. So we need LangChain, PG, and let's go to the LangChain documentation because I need two more dependencies. So LangChain, since we are going to perform what I mentioned before, this retrieval augmented generation application, it has a lot of abstractions for that retrieval part. So retrieval means I am getting data from a document, that I'm getting data from something. So here we have different document loaders. And one of those document loaders is a YouTube loader. I can load, for example, a text file, or I can load a PDF, but I can also load from YouTube. So I'm going to use the search. We have web loaders. This is the get YouTube transcripts. So let me install these two dependencies that we are going to be using for fetching the transcripts from a YouTube video. I need these two, YouTube's transcript and YouTube i.js, along with LangChain, PG to support pgvector, and we can start building our application. Okay. So how are we going to do this? First, I'm going to be creating a library. So let's create a library on my web project. And let's call this library AI. So this is going to be a class called AI. I'm exporting this class. And this class is going to have two methods. One is load document that will receive a YouTube URL. And the other one is going to be query that is going to get a question. So those are the two methods we will need for our application. Then I will create a static method. Let's call create, which is going to be a constructor for my class. Why I'm using this pattern here, a static constructor? Because pgvector classes on LangChain are asynchronous, and I cannot have an asynchronous constructor in JavaScript. So here I am doing some sort of pattern to create an asynchronous constructor. You can see that I have an asynchronous class, an asynchronous method, which is static, but I am returning an instance of the class. And I will be able to perform asynchronous operations within this method. And now I need to import the classes that I will be using for the logic. So first, let's focus on the document loading. I need to import YouTube loader. It's with lowercase YouTube loader from, and this is LangChain document loaders web YouTube. Okay. How do I know this? From the documentation. In the documentation, we are importing the YouTube loader from this path, and then we will be able to load the video from an URL. So now let's load the video. Okay, how can we load the video? Let me create a loader here. So this is going to be a loader. It's going to be a YouTube loader. Create from URL, the YouTube URL, and the language. The videos are going to be in English. And I want to get the video information. So this is going to fetch the video metadata, like the title, the description, some other information that is stored on YouTube. Yeah, when in doubt, read the dog. The dog has everything. I don't know anything by memory. I just have like some examples here on one screen, but sometimes I need to go to the dog. Okay, we are going to be loading long videos. This code live is going to be an hour long. This is a lot of text. Have you read the concept of tokens in AI, in large language models? So there are like certain models that support a number amount of tokens. So let me go to the OpenAI documentation. Here, documentation, models. There are different models. We are going to be using models for generating the text, the questions. So let's say we are going to be working with GPT 3.5, and we have different amount of tokens per model, like 4,000 tokens, 16,000 tokens. A token is just 4 characters. So the model can only handle at the same time this amount of tokens, this amount of characters. So if we send a lot of text at the same time, the model will fail. We will need to split the text that we are getting from the YouTube video into chunks, like pieces of text that are going to be converted into vectors. This is being done with embedding models. The embedding models or embeddings are numerical representations of text that can be used to measure the relatedness between two pieces of text. So this sounds something similar to doing the similarity search in the vector database. So we are going to be using embeddings for this. OpenAI has the embeddings API, but there are other embeddings APIs that you can use. Hugging Face has one. There are other applications that you can use to extract embeddings from a text. I'm going to be using the OpenAI solution for this. And basically, when I pass a text, it will return the vector representation of that text. And OpenAI uses this model called Text Embedding ADA 002, which, depending of the model, it has, depending of the version, it has a number amount of input tokens. As we can see here, it's just 8,000 tokens. So we will need to split the text into smaller chunks so the model doesn't fail. So what next into this operation? We have the loader, then we need to load the document. So let's load the document. This is going to get all of the transcripts. So doc, await, loader.load. So here we are getting the document of that video. Let's test this. Let's write a test for this thing. Okay, so what do we have for testing here? Let me see. I have the time. I have tab. Beautiful. Let me write a test, new file. This is ai.test.js. And with tab, should we use Copilot? let's use Copilot. Why not? Let's use AI to write AI tests. So I'm going to use GitHub Copilot, write a test for the selected code using Node tab. This is beautiful. I don't need to think about this. Is going to give me some basic code to test. Wonderful. So let me see if this works. I don't think so. Let me get the test. This didn't work. So import test from tab. And I need to import AI from leave AI.js. And I need to get this create. And then I need to do an AI load document. And let's see if this runs. Okay, AI test is passing. Now what I want to do is debug to see what I'm getting here. So I'm going to be opening the JavaScript debug terminal and adding a breakpoint. And I'm executing npm test again. And it stopped. Okay, so now in the debug console, what is doc? I want to see what is doc. It is a document. And the document has a page content, which is some music. We are no strangers to law, you know. I am not going to open that video because it might be a copyright hit. So let's open something that we know. I don't want to have copyright issues in this channel. So let's open something that we know. This is a video I recorded, so I know that I can use this without having copyright issues. And let's change the URL. Let's try again. Yeah, we don't want issues here. Okay, now let me take a look at the debug console. Document, text. Okay, you can see here the page content. It says, hello, my name is Julian Duque. This is something that I know. And it has the metadata, which is the author, the description, the video, the title, the statistics of the video. So the YouTube loader works. So now we are getting the document from YouTube. Then we will need to split it and to store it in the database. So we are going to leave this terminal here, getting back to the other one, and continue building our class. LangChain also has document splits. So if we go to the documentation, we can search for recursive. It's called document splitter. It has classes to perform the text split. This is the name of the class that I want to open. Okay, well, it went to the proper documentation and changed the color for some reason. But yes, we have a class that it's called recursive text splitter. And this recursive text splitter is the one that is going to get the document, that document class, and is going to give me the chunks. So let's get the chunks. So now I am getting the chunks in the next step. So first, I will need to import that class, recursive character text splitter, from LangChain text splitter. This is where it lives. And then I will need to perform the text split. So this is going to just give me different documents instead of just one. So I'm creating a splitter, and the parameters of the splitter are going to be the size of the chunk. Let's have a chunk of 500 characters, and then an overlap, a chunk overlap of 0. This is pretty much when I am cutting the text, sometimes I am missing or I am cutting in between two sentences. So the overlap is just cut a little bit more, and on the next cut a little bit less, so we don't miss the overlap. We can add that overlap of 50 here. That's okay. And then let's split the documents. So now we are going to split the documents. This is not the right syntax. So await, splitter, split documents. And let's return docs. I want to do the step by step so we understand how it is giving us the information that it will be stored in the database. So then run the test again. Oh, we removed the breakpoint. So let me add the breakpoint again. And now I need to take a look at doc. So doc, now it contains 10 documents. So those 10 documents, all of them has the page content and the metadata. The metadata is going to be the same because it is the same document, but we have just chunks of the YouTube transcripts. So this is what we are going to be storing in the database. But before we store those, we will need to convert this into embeddings. So now the next step is to add the documents into the PG vector store. So let's create a PG vector store. So we are going to be importing the class PG vector store from LangChain vector stores PG vector. And again, you might have guessed there is awesome documentation here. If we go to vector stores, we can see a lot of different implementation of vector stores. We have PG vector, and we have the documentation here, how to use PG vector in LangChain. Perfect. So remember that we have this constructor. So we will use this constructor right now. So we can pass some options. Okay, so let me have a constructor here, a normal constructor. This constructor has some options, and we will need to have a PG vector store private property. And pretty much this PG vector store is going to be passed from here. So I am going to create a PG vector store instance here. So then let's create a PG vector store, and we will pass it on the constructor. So this is what I'm doing. On the static asynchronous method, we are creating an instance of PG vector, and then we are passing it to the constructor. So this is available on my methods because I'm going to be using this on the query and on the load YouTube method. Stay with me. This is going to make sense in a moment. Then the PG vector store, it's not going to be like that. It is going to be await pg vector store, initialize, and now it needs some options. And the options, it has Postgres connection options. Now here I pass the Postgres connection options. One is the connection string, which is coming from process and database URL. This is coming from Heroku. And the SSL options, this is reject unauthorized false. And I need some other options from these. Okay, the table name, this is going to be called video content. This is the table that is going to be stored in my Postgres, and it has some columns. So I'm specifying the columns, the ID column name, it's called ID. The vector column name is called vector. The content column name is called content. And the metadata column name is called metadata. Let me confirm from the documentation. ID column name, vector column name, yes. And I am initializing the vector store. Okay. So I'm initializing the vector store. The first parameter is the embeddings. So I need the embeddings. So let me open the embeddings. So this is the class that is going to convert those documents into vectors. So this is the first argument here. New OpenAI embeddings. And the second argument is the configuration. Julian, what is the default version of PG Vector in Heroku? I think it's 0.5, but we can check. We can go. Oh, no. Not on the debug one. Let me go on the terminal, Heroku, PGPSQL, and hello, Sebastian, welcome. It's good to have you here. And to get the version, there it's a query. I forgot the query to get the version. This is the version. This is the query. 0.5.1 is the version that we have installed. I think this is the last one. Okay, let's continue. Where was I? Okay, so now I have the PG Vector instance set up. I need to fetch the configuration from Heroku. So let me get the Heroku config as a shell and add it to .emp without overriding the OpenAPI key that I have. So now I have the database URL set up. And then what I need to do is await this PG vector add documents docs. So I am adding the documents to my database, and what we can do is we can return the information from the document. So we can get the title, let's say the first document that we have. We can get the title and the description and the source. Okay. And let's take a look at this. TOK doc.source, no, T equals doc.source should be equal to this, because this is the one that we are loading. So here we are making sure that we are loading the exact document. And if everything works, we will have vectors in our database. Let me run the test without debugging. Fail. Okay, we fail here. Why? OpenAI or Azure OpenAI API key not found. Okay, there is one step missing. I'm going to be installing the .env library that loads the .env configuration files. And here I will need to import dot. I forgot how to import this. Import .env slash config. Yes, let me see. Okay, now the error is different. I mess it up. Is .env, not .env with an M. Let me see. It's running the test. Okay, it's taking some time, but it seems it's performing now the operation because it is not failing. If I go to my database, okay, here we can see the new table called video content. Select count from video content. We see that we have 10 documents. They are stored. Select content from video content. We have the text, but we get vectors because there are going to be a lot. So I'm storing the information right now in the database. It's in the database. The tests, it failed because why? A timeout. Huh. But it is doing the job. Believe me, it's storing the information. Okay. So I have half of the solution ready. I'm already storing information. Now what I need to do is to implement the query. How can we implement the query? Now we have PG vector. Now what we are going to be doing is to create a chain. This chain is the one that is going to let me ask questions to the video. And for this, we are going to be using a QI chain in LangChain. So let me go and start in the asynchronous constructor. We are going to create a QI chain. So let me create that chain. This chain is going to be called retrieval QA chain. So let me search the documentation for retrieval QA chain in the LangChain documentation. This is retrievers. No, this is in chains. Chat models, chain. Let me search it here. Easy. Okay. So this is the retrieval QA chain. So we will need a model first. So before we create the chain, we will need a model. So we are going to be using a model. And this model is going to be Chat OpenAI. And we will use the model. What model should we use? The GPT. Let's use the last GPT 3.5 model because it is fast. This one. I don't use GPT-4 here because it is expensive and slow. So I'm going to be using 3.5 Turbo. Chat OpenAI. And let me import the Chat OpenAI module here. And the other one is the QI chain. These are the two we are going to be using, the retrieval QA chain and QI stuff chain. And let's continue. So now we need to get a retriever as well. So remember that we are going to get documents, and those documents needs to come from somewhere, and our somewhere is our PG vector store. So the PG vector store is the one that is going to be used to retrieve the documents when we ask a question. So this is going to be doing the query for us internally. It's not guess retriever, it is as retriever. Yes, that's the proper name of the method. And then here we are going to combine the document chain with the load's queue chain, and we need to pass a prompt template. So let me create a prompt template, and we will create the prompt template in a moment. Then we pass the retriever. Then we say, yes, return the source documents in case we need the metadata, for example. And the input key is going to be called question. So this is how you set up the retrieval QI chain. This is a class from LangChain. And with this setup, I will be able to ask questions using a prompt template. So now let's set up the prompt template. So the input variables of my prompt template are going to be the context and the question. And the template, this is the key of everything. So this is the prompt that I will be sending our LLM. And this is the one that is going to get the question and the context that is getting from the database. So now here is you will answer questions about Salesforce development from the transcripts of a YouTube video. The transcripts are the following. So I add the context as a variable, and then I specify the question, and then you specify the answer. And since this is a prompt, you can use any prompt engineering trick here. For example, if you don't know the answer, reply, sorry, I don't know. So the transcripts are the following, and this is pretty much the prompt I am building with this prompt template. Now I need to reuse that chain. So I'm going to be passing that chain to the constructor. I'm setting that chain here. So I'm just bubbling up this asynchronous constructor. And I think I have everything now to ask questions. Now, the implementation of the query is just return whatever I'm going to be calling the chain with the question I am passing. So basically, I'm calling that chain that I set up with a question, and what it's going to do is going to use that model, the chat OpenAI, with this prompt is going to perform the query using the retriever. So the question is going to be transformed using the embeddings, is going to perform the query, get all of the context that is related to that question, and it will create this prompt, and it will send the prompt to OpenAI, it will get the answer, and it will reply. And we can add this as verbose, so we see what's going on. And let's test that. Test a query function. This is asynchronous. And we are going just to do something here. We need the AI. And what is the difference between a class and an object in Salesforce? I don't talk about that in my video, so let's see if this works. Answer and the okay answer should be returned the end. But let me stop here to take a look at the answer, okay? So I'm sending a question. I am performing the query to the AI, and I will be able to see if it's returning something. I'm going to ignore this one so we don't have any issues. And let me run the test. I am not going to have time to implement the API, so this needs to be for a second session. So what happened? What I did? Okay. Oh, I am having an error here. Oh, it's not this. It's prompt. The prompt template. It is from prompts. Yes. Okay. Let me see. Okay. Now I have the question. Let me see if we have the answer. If you see here in the debug, you can take a look at the logic because I added this flag verbose here on the chain. So I'm starting the chain. I'm starting the conversation. So I'm getting multiple steps to get the result. So this is the question I am sending. Then I am entering the retriever with that input. Then I get the output. The output, it is from that question, it is getting the following context. So these are chunks from the video. So check the following quick take by Aditya where he explains more about blah, blah, blah. And then he gets another piece of context. There's another piece of context. So he's getting some pieces of context. Then he build the prompt. Now, let me see where is the prompt. He's transforming everything. Okay. So let me see if we got an answer here. Oh, what happened? It failed? Oh, maybe it failed because I took too much time. I need timeout. So let me see if we are not that slow and we are able to get the answer. So this is the prompt. You will answer questions. It is sending the prompt, but the test is getting into a timeout, so I'm not getting the answer here. That's beautiful. So let me create a executor so we do something faster. Instead of a test, so we don't get into that trouble, we are going to run this file. And let's console log answer. Node index. No, without debugging. Node index. Okay, is performing the logic. Let's see if we can get a response. It got the response now. Okay. Text. In Salesforce, a class is a blueprint or template for creating objects. It defines the properties and behaviors. It's responding something that shouldn't be. Let me modify the template. If you don't know the answer, or if the answer is not in the context, reply, sorry, I don't know. So it should respond, sorry, I don't know, because that video doesn't talk about the difference between a class and an object. So we will need to tweak the prompt in our case. But as you can see, the prompt that it's sending to OpenAI is you will answer the questions, then it's sending the context, and then it's sending the question. And the response is, sorry, I don't know. So now this is responding as I want. But if I ask something that it's on the video, how to perform a HTTP request on Lightning Web Components, because the video talk about that. And if I execute this, it is getting context, and the answer should appear here. To perform an HTTP request on LWC, you can use the Fetch API. The Fetch API is the standard HTTP request for JavaScript and can be used in LWC components or any other JavaScript application. Phew! Just in time, we weren't able to implement the API, but use this logic, add it into a couple of routes in an API, and you have an AI-enabled application. We are using Heroku's PG Vector to be able to store those transcript video representations into our database, and we are performing this retrieval by using this RAG technique, retrieval augmented generation. As you can see, step by step, you can enable the verbose option. If you don't want that much output, you can disable both the verbose and the source document, and you only get the answer. See, we don't have the debug information, so that's a way so you can debug your queries, you can debug the chain if it is working properly, and there we go. We have the answer we were looking for. That was pretty much what I had for you all today. Thank you very much for joining me. I'm writing a blog post right now for the Heroku blog that will talk more about how to create this API. But I already have something for you. Let me go to the developer portal, to our blog in the developer.salesforce.com blog. There is a blog post that I published on November 2nd, Building AI Applications with LangChain and Node.js, where you can find all of these things that I talked to you today, all of the logic behind RAG applications, what is LangChain. I am not using PG Vector on this one. I'm using Face, which is an in-memory vector store. But if you want a production-ready application, I would recommend you to use PG Vector or a vector database for this case. That's it for all. Thank you very much for joining me on this Code Live, and see you on the next one. Bye-bye.